Okay, excellent. Okay, so good afternoon to those who are here and all of the people I'm sure who are about to spill in from the rest of the conference. And welcome to the Space Showcase Highlight Hour. So we're going to have 6 businesses talking to us about their journeys into the space sector and a chance to ask questions for them afterwards. 6 businesses, 10 minutes per business. It's going to move pretty rapidly. And in order not to take up much more time than I deserve, because this isn't about me, I'm just going to hand over straight away to our first business, to our first speaker, which is Rosie Hull from Skyrora. So yeah, a big round of applause for Rosie. And you can use Lecton or...
Sure. Awesome. So thanks so much for having me. I just want to kind of set the scene first by giving you a bit of context about who Skyrora are. So we're a company that's based in Scotland that are developing a range of space technologies, but our main goal and focus is the development of our orbital launch vehicle, the Skyrora XL. So this is a 3-stage vehicle that's going to take around 315 kilograms of small satellite payload to low Earth orbit. And the goal for us as a Scottish-based company is to manufacture our rockets in Scotland and also to launch from Saxford Spaceport, which is based in the Shetlands. And doing this, we hope to open up access to space to all of the UK small satellite manufacturers and also the European ones as well. So today I kind of wanted to tell you a little bit about our development, but I also kind of wanted to give you a bit more insight into the more interesting challenges that we've experienced while developing our launch vehicle, specifically focusing on our engine test site, which is currently based in the south of Edinburgh in Midlothian. So just to sort of set the scene on what kind of things we do at an engine test site. So whenever you're developing a launch vehicle and developing rocket engines, as we do in-house, you have to put those engines through a variety of different tests before you can actually launch them on a rocket. And one of the biggest and most final tests that you have to complete whenever doing this is the static fire test. So to explain how that looks, it's a test where you pump the rocket engine with fuel and oxidizer and you light it as if it was going to actually take off. But instead of letting it do so, you actually hold it down, and this allows us a chance to actually monitor a different selection of different parameters, so the pressures of the engine, the sort of temperatures that it's experiencing, and just to make sure that the engine's ready to go before we actually test it during launch. And so for us, we do a large number of these static fire tests before we actually can say that an engine is ready to launch. And whenever you're looking at a test site for this kind of capability, you have to find an area with quite a large safety radius, just because obviously if something goes wrong, it wouldn't be ideal if anyone was nearby. And so I kind of wanted to take you through some of our challenges when actually finding this kind of test site. So our vehicle has 2 main engines, our smaller 3.5 kilonewton engine, which carries our satellite payloads on the 3rd stage, and then we also have a 70 kilonewton engine, which powers our 1st and 2nd stage of our Skyrora XL. And whenever we first started, we had an engine test site in Rosyth, which is in Scotland, to allow us to test our 3.5 kilonewton engine. But whenever we were looking to test our 70 kilonewton engine, we had to find a much larger site with a much bigger safety radius. And our team spent around 2 years searching for this site, and we eventually found a site in a quarry just south of Edinburgh in Midlothian, where we're currently based now. But I would say that the actual development of this site wasn't always a perfect situation. So we found the site, we got planning permission, and we did an environmental assessment of the site. We also did an archaeological assessment of the site just to make sure that we were allowed to begin construction there. And everything was fine, looked perfect, and we started construction. And I just want you to kind of imagine a little bit about what you think the biggest challenge that we might have experienced during the setup of this site. So you think maybe like a technological problem, or maybe like planning permission, something like that. But it wasn't, it was newts. So I'm talking about like the amphibian style newts. So our diggers, our construction team got on site, they began digging, and then all of a sudden they happened upon a little kind of pond with a bunch of newts in it. And you'd think, oh, well that's fine, we could just move ahead, maybe move those newts to another site and carry on. Turns out there's not a lot of endangered species in Scotland, but one of them is the crested newt. And if you accidentally harm or move any of these newts, you could get an unlimited fine or 6 months in prison. And so I don't think the construction team wanted to take that risk, and neither did we. So what we had to do was get our team, for those of you that know Derek Harris, our business operations manager, we had to get Derek with a tank and a net to catch these newts, and then to bring them to a variety of different vets to make sure that they were not a crested newt. So thankfully for us, that was not the case, and they were not endangered type of newt, so we were able to move forward with construction and just move them safely to another area nearby the quarry, which was great. But I just kind of want to lay the scene that something that could have literally stopped our development of this engine test site was newts. And I think the biggest thing that I can kind of pull from that story is that even the best laid plans at a rocket company with all of the assessments in place, that all those plans could be changed just by one simple thing. And I think thankfully we managed to overcome that quite easily, but I would just say that with any startup or any small company, there's always going to be very interesting challenges that you just don't expect until you actually get there. But yeah, despite that challenge, we have done around 2,000 seconds of successful static fire testing of our 70 kilonewton engine, and we also hope to launch our Skyroar XL, our first launch in Q4 2025 from Saxford Spaceport. So yeah, that's just a bit of context about Skyroar.
Is this on? Can you all hear me all right? Excellent. So thank you for sharing that. When you said that the work you do involves holding down rockets and lighting them, I didn't think the challenge you would have would be around newts.
Exactly.
As well. So can you tell us a bit more? I heard, have you got a suborbital launch vehicle, Skylark L?
Yeah. So in terms of how we're developing our Skyroar XL, we've actually started with a smaller launch vehicle, so it's a Skylark L. So this means that we can do launch tests and test our technology for our orbital vehicle, but on a much smaller scale, so it's much less expensive and much less risk whenever we have those launch attempts. So we had one launch attempt of our Skylark L in 2022. From Iceland, but we do hope to have another launch of that vehicle from Saxford Spaceport very soon. We're just waiting on our launch license from the CAA. So yeah, hope you'll see that soon.
Very nice, thank you. And by the way, on the app, audience questions are open, so if anyone does want to ask anything in the live Q&A, feel free to. I guess just a question around today, the conference. Who are the types of people you're looking to connect with as you're kind of moving forward from today, your growth and whatever comes next for Skyroar?
Yeah, absolutely. So I think for us, one of our main goals at the moment is finding a few more payloads for our first demonstrator launch. So if you're a small satellite company interested, then definitely feel free to chat to me afterwards. And as well as that, we're quite a collaborative company, so we've applied for a few different grants with a bunch of different universities and other companies and things like that. So if you're interested or think you might have something that could maybe benefit us or benefit you, we can maybe work on together, then definitely also feel free to have a chat with me.
Nice, thank you very much. And I guess maybe my last question, if you were to go back to when you kind of started working in this space, is there any advice you would give to yourself, anything you would have done differently?
I kind of want to bring it into a personal space, if that's okay. So I've been in this job for around 3 years now, and it's definitely been a very, very incredible, but maybe a slightly chaotic experience just because we're such a small and agile company. But I would say that something that is really beneficial to me is just the ability to sort of take on feedback from people. So I think sometimes it's not always nice to hear when you haven't maybe done something quite right, or you maybe sort of could have done something a little bit better. And I think the best way that you can grow as a person in this industry is just taking on that feedback and having that self-awareness to sort of make those changes in yourself and become a better person in the industry. And I think for me, with public speaking, this is something that I'm definitely still quite new to, and I've definitely been quite nervous over the last few things that I have actually presented on. But I think just over time, getting that experience, getting that feedback has really helped me to grow and become a much better public speaker. So yeah, that'll be my advice.
Nice, thank you very much. And for sharing that, and thank you for speaking at our highlight hour. So yeah, a big round of applause for Rosie.
Thank you.
Our next speaker is Neil Buchanan, co-founder of Lodestar. And Neil, you're welcome to present from the lectern or from the chair, however you feel most comfortable.
Thank you very much. Okay, wonderful. Everyone here, thank you for choosing to listen to us over sandwiches. I promise there'll be stuff left over afterwards and we can all get lunch together. But very nice to be with you all this afternoon. I'm Neil, CEO and co-founder of Lodestar, and we're building the frontline service to safeguard all of Earth operations. Before I get into what all of that is, something I did at a previous talk was actually kind of went down well, taking a step back and just reminding everyone, like, this is the most exciting time to be alive. We've spent 2 days now talking about space and all the things we can do in it. And every one of us in this room is getting more and more out of the space environment. The reason we were able to navigate here today, the way we're able to communicate with our loved ones, even the new drugs, the materials we'll be relying on in the coming years, all coming from the space environment. And with that growing use of it comes a growing dependence. And with a growing dependence comes a growing vulnerability, and that's where we come in. But if I've learned anything in the 1.5 years now of running a space company, it's all about solving an actual customer problem that exists today. So here's 2 examples. We're seeing an increasing need on the commercial side to basically go up and fix satellites in orbit. We've seen Viasat 3 in particular, $700 million of hardware sent up at the start of last year, shaking a bit too much, breaking in space, and then now it's going to cost $24 billion in lost revenue for its parent company over the next 10 years. So there's a huge commercial opportunity in being able to go up and fix things in space once we've sent them up there. And on the national security side, we're seeing an increasing amount of behavior by bad actors, whether it's countries like China or Russia, showing force, projecting what they could do, and ultimately putting stuff up there that we don't know what it is and could potentially be a threat to us here on Earth. So all of this points to a fact that an analogy I really like to use is that space is still a frontier. And after we've built the railroads with rockets from SpaceX and Rocket Lab, after we've worked on wagons with the space taxis and OTVs, and the saloon with companies like Axiom and Vast, what we think we need is a sheriff in town. And that gave me the nickname of Space Sheriff at my last conference, which I'll definitely need a PR agency to try and shift. Anyway, what we're building is basically taking solving the problem of contact dynamics in space, this idea of how do you grab stuff, how do you release stuff and make sure it doesn't fly off in the other direction, and basically making sure and pairing that with the opportunity to go out and basically be a space sentry spacecraft. What we're trying to do is kind of become the first responder service for in orbit, being able to inspect, protect and repair assets of really high importance and national security, and the robotics and everything we've been working on are kind of central to that core mission there. Team-wise, we're 2 founders, myself, Neil, my background in a lot of deep tech stuff, starting off with Hyperloop, then working on to rocketry and ending up with metal 3D printing in space, and my incredible co-founder, Thomas, with his background in 3D printing and how you could turn lunar regolith into a manufacturable material to one day build things on the moon and Mars. We've got a crack team of incredible young career people, and also pairing that with experience and understanding of the space environment and working with them from that perspective. In terms of advisors, we're advised by the former head of the European Space Agency, one of the legendary exited space founders over in the US, who also happened to be Bill Gates' first in-house counsel lawyer, which is very useful to have when you're trying to solve problems in space. And ultimately, we're a team of about 6 or 7, growing to about 10 by the end of the summer. So going for a really exciting growth phase at the moment. I kind of wanted to finish up on this talk by, first of all, touching on a recent win we had, and then also kind of looking to the future. So if you come over to our stand on number 3, right by the entrance, you'll be able to see some of the microgravity demonstration flights that we've just finished. Project Inception, our resident astronaut Kieran got to go up there on float in microgravity, and was the first time we tested our robot arm in a zero-G environment to show how we can track, how we can behave, how we can interact with uncooperative assets in the space domain. So he'll be more than happy to talk to all about the time he flew around in microgravity for that. And then to finish off, we're a small company, and with every day we're building momentum like no tomorrow. So if anyone in here thrives on the idea of solving the hardest problems in space for the most important reasons, please come speak to us. We'd love to find a role to work with you guys and get you on board for this really important mission. Thank you very much.
Thank you so much
Thank you
for the talk. Okay, so I mean, I've got a a few questions. Space Sheriff is a pretty good title as well.
Thank you. I've got the Stetson to go with it as well. I just forgot to bring it.
Is Lodestar like Lone Star? Is there something to be said for that? The
I think
Lone Star Ranger?
there's a branding thing we could do that at some point in the future.
Okay.
For sure. We'll get the cowboy boots, the belts.
Nice. Sorry, this isn't the sort of questions UKSA wanted me to ask when they got me up here. Well, we spoke earlier, and you mentioned that you're passionate about building a talent base in the UK to address kind of European needs and kind of keeping that here. Can you talk a little bit about how you're doing that as a company and why that's an important thing for you?
Yeah, 100%. So I think if you look at what students do when they go out of university right now and they're engineers, they either go into a grad role, sub 30K salary, maybe 35 if they're doing okay, or they go into finance or into management consulting and they spend a lot of time making a lot of money, but ultimately not really driving that much impact, not really making a tangible impact on the world. And I think in the UK we have a real shortage of opportunities for you to actually go out and get your teeth dug into something that actually makes an impact. We can earn a decent salary, but really be working on kind of a proper mission-driven thing. And I think in the space domain especially, that's something that we struggle with. Like brilliant companies like Lockheed, Airbus, they all have grad schemes, but they're typically small cogs in massive machines. And I think what we're trying to build here is this kind of beacon, this lodestar, or so to say, to basically allow people at this early stage in their career to take their experience, take their background in student projects and student teams, and apply that for a problem that really matters very on in their career and just hit the ground running. And I think that also comes conversely with people who are experienced, who have been in those big corporates, who have worked in these really big kind of cumbersome machines of big corporate, wanting to kind of go back to their roots, go back and take a really exciting opportunity. And we're seeing interest from Americans wanting to uproot their entire families and move over to the UK to come and work with us. Such is the importance of the problem we're doing, such is the excitement of this opportunity to work at a really early stage company. And we really want to take all this talent and put our company as kind of the face of, let's build this stuff in the UK, for Europe, and not have that brain drain to other industries.
Thank you very much. In terms of satellites being, I guess, maintained or repaired in space, how important is it that they're designed from the start to be like manipulated in space? And do you see the space sector as like embracing that? Is that something that's happening, or is that a bit of a challenge?
Oh, brilliant question. I think my experience would be that people often have the mindset of if it's not broke, don't fix it. Like, we've done things before, we use space heritage, we do stuff that's been like done in the past, and there's not a huge appetite to try and all of these, like, you know, be the first one through the wall to try this new type of satellite that has this ability to kind of be modular and place. Like, I think that would be brilliant for the future, but right now, is there the business case? We don't know for sure. So what we're really focusing on is being able to support stuff that's already there in orbit, and that's around the grapping, that's around the gripping, and being able to basically interact with stuff that's already been sent with no idea, no even thoughts about it one day being able to be repaired, and being able to work with that. Because once we've been able to solve that problem, the future and where the market takes us is going to be ripe for taking with the technology we've built.
Okay, and I guess once you've shown the value of being able to do that, people might start designing that in from the
Yeah, the classic chicken and egg space problem of they're not going to do it if they don't have an opportunity to actually go.
The old chicken egg sheriff story.
Chicken and egg sheriff story.
Okay, my last question. What are some of the roadblocks that you found on your growth pathway, and have you got any advice for any businesses coming through the same path?
So funding is difficult, but I don't think funding is the hardest one by any means. I think talent and being able to play the game of like how you put something in space from this country is a very big blocker. So we've managed to get venture capital money. We've raised about $1.5 million to date. So we've been like in a good position to actually attract talent, attract money from outside of the UK, and that's been really good. But ultimately, like to be able to get space heritage, to be able to get like the actual people on board, like those senior engineers, they've got notice periods. They've got 3 months. They need to move country. We need to apply for visas and do skilled worker sponsors license to get any of that really strong talent from the US who's worked on these things before. That all adds up. And that means that by the time you raise the money, and if you think it's easy, like once you get started, there's a big storm coming for you. So that's what we're kind of like working through at the moment. And I think on the regulation side as well, like being able to put stuff, being able to license and work with radio frequencies, like it's sort of chicken and egg there, where you have to put forward like a really complex plan and a fully kind of described mission to the Civil Aviation Authority to start the license process, which then can take 6 months. And in all that time, like, things could have changed. And you kind of need to understand at the very beginning, like, what roadblocks are going to be on the way. And I think there could be some improvement for that process there. So if there's anyone from the CAA here, we'd love to speak with you after and try and see if we can smoothen that process. But those are kind of the things that come to mind, like understanding money isn't the biggest blocker by any means. You have to ultimately plan for the road ahead and assume success in the fundraising and stuff like that.
Nice. Thank you very much.
Thank you, everyone. Come see us at stand number 3.
Next up, I'd like to invite Sarah Lau from Star's Edge. Yeah.
Okay. Hi, everyone. Really great seeing you all here today. My name is Sarah. I'm the current CEO and co-founder of Star's Edge. And let me tell you a bit about how we became what we are, what are we doing, and what we plan on doing in the future. So Star's Edge, new startup coming up. We are doing propulsion, but not just any kind of propulsion. We've been able to actually be one of the first companies in the world to actually crack air-breathing propulsion for the very low Earth orbits. We have a working engine, and we're looking to do much more with it. We've also able to do the first throttleable electrical propulsion system for satellites, similar to a car, low power, high efficiency, high power, low efficiency for fuel. How did we get here, though? So we've been quite a lot of places. We've had a lot of great ideas, and we've had a lot of different great company moments to lead us to where we are, and a bit of a pivot as well. So I come from a military family. I moved around quite a bit in my life. I was born in Belgium. I moved to the US. I was in the UK, in Portugal, all over the world. And I got to learn all these cultures, see all these types of work ethics, all these types of scenarios, and ultimately it brought me here to the UK. I've always been very passionate about sustainability and ended up doing a lot of volunteering on energy savings, water savings, all these types of things, but always had a massive, massive passion for space, and which allowed me to get a bit of where I am and the culmination of everything. 2 years ago, I did a lot of outreach work, a lot of volunteering work as the head of a student space society in Cranfield, biggest student space society in the country, and we did amazing. All the STEM outreach, all the amazing things, and through a lot of this work, I ended up finding a lot of like-minded people, a lot of really great talent in the industry, which I do feel bad aren't actually getting employed at times in some of these bigger companies, but people who've been doing so amazing and have such a massive drive and passion and want to do more. People that I worked with, people that I had a chance to interact with. We ended up winning a sustainability entrepreneurship competition as well, and we just loved working with each other so much. We loved the team ethic. We loved the innovation and passion we were out there creating, and we thought, this is our time. We have to go further. We have to do something. We have to do a difference. We were actually thinking about different ideas. Okay, we have the team, we have the passion, we have the expertise. What do we actually do? We're looking at things like robotics as well, looking at things like space dash cams for satellites. Let's put a dash cam to make sure if it gets hit, we know who hit it. All these types of things. We ended up settling on my research from 2 years ago, making these air-breathing engines for aviation initially, but we actually were thinking, oh, air breathing, there's no air in space. How are we going to tackle that? Well, let's just strap a fuel system on it, get it into like any other satellite, attach fuel onto it, feed it to something. Great, it works. And that's initially what we were doing. We were selling sustainability. We were able to make a system that runs more efficiently than other systems, that can give you propellant that isn't as corrosive, as pollutant, as expensive. But ultimately it was a lot of sustainability is hard to sell, and we were getting a bit away from our roots, which is when we really decided to pivot back to where we came from, the main idea of the product, which was, it was an air breathing system in the core, and it should continue being an air breathing system. There is so much value when it comes down to it, being able to make an upper atmosphere satellite in the orbits of about 150 to 250 kilometers, just above the Kármán line, a satellite that can give you Earth observation of 3 times the power, telecommunications of 5 times the data transfer, much higher data for surveillance as well, and all these types of things. Our system in the end is a bit of everything. A system that doesn't have pressure, doesn't have a heat signature, does just about anything that you want to do, and is demonstrated. We've demonstrated in lab, and we have a great momentum. Although we only started in December, we have a working prototype, and we're looking to scale it with the collaboration of different partnerships. University of Surrey is supporting us, as well as other venture builders, as well here today. And we're doing amazing. We have a team of 8 at the moment, both from business and engineering, and we are looking to go much, much higher. We want to give the value ultimately to who needs it and create those partnerships. And that's why we're here. That's our story in the end.
Thank you very much for that. So you talked a bit about your growth.
Yes.
And what's coming next. So can you talk a bit more specifically? What sort of support is going to be most valuable to you moving forward? What are you looking to from the ecosystem? And I guess on that, how much of that do you see out there and you would know where to go, and how much is still you're unsure of the right pathway?
Okay. Thank you so much. So we have a working demonstrator. We know our engine works, and we will be getting into space by 2025. That's not an issue. What we're looking really in the industry is finding partners to work with, people who can help us maybe with the satellite platform to actually put the satellite into space with these capabilities, or ultimately end users who may use up our services, the value we're creating, whoever may be needing it. It's such a high value technology with dual use as well for military applications. It's a shame for it not to be used. We're very passionate about the idea, very passionate about everything, but we know the value it can bring. From an Earth observation, giving better resolution to city observation, disaster monitoring, weather forecasting, agriculture, all these types of things, the maritime activities as well. We know there is so much value there. We want to bring it to the right people and work with the right people to do it. We've been in chats a lot with the Americans and with a lot of companies in the UK and Europe, seeing who ultimately will be best to work with, some bigger companies, some smaller companies, but we want to do better. We have such great momentum, we don't want to hamper it. We want to take it as far as we can.
Thank you very much. We spoke earlier about diversity in the space sector. So I guess I'd be interested in your thoughts on what you think the sector should be doing to embrace diversity and also bring in the kind of next generation of talent.
So space is by far the most diverse sector. As a lot of you have been seeing, space can do everything. We can do not just satellites, but also now pharmaceuticals, materials, all these types of things. Anyone can work in space and anyone can have a place in space. A lot of times it's a bit of a shame with the very high barriers of entry to get into space. A lot of students who have this skill set, they've done some internships, they've been at university. A lot of times it's just not enough to break it into space, which is such a shame. It's such an area of high innovation. We need that talent, we need that creativity, we need that passion. And a lot of times it's taking that risk on someone who may be less experienced, really growing them yourself into what ultimately you need in the company, giving them those opportunities to grow, to be better professionals in the area, and just doing more when it comes down to it. It's such a shame to see someone maybe from a marketing background, a corporate sustainability background, an engineering background that isn't really related to space, who are very passionate about it, not wanting to pursue it because there is just no place for them in space. Everyone is welcome in space. That's what we've been doing as a company, getting people from just around everywhere, people who we know I've worked with personally, I know they're great, and giving them those opportunities to grow, to climb, to find their own space in space.
Thank you. And you mentioned that you've lived and worked in various places around the world. What's your perspective on the kind of UK space sector as opposed to what you've seen in other places?
The UK space sector is very interesting how it's moving more on the privatization and commercialization of space. The US is still very dominated by the defense side of things. You cannot work in space if you're not an American citizen, and usually because of defense and national security concerns. The UK is very much leading on the general more side of commercialization. It's really, really great to see. Specifically on the sustainability side, we've been seeing so many great works from a variety of different companies. It's a place where I've seen a lot more diversity from people in terms of different cultures, different ethnicities. The UK is doing really well, but there's also the potential for collaboration more with these other sectors. I know the US is wanting to collaborate more with the UK, but we also shouldn't shut our doors to people in the local area in Europe and working more with them. I know Belgium, the Netherlands, a lot of that area is pushing a lot for it. Spain and France, those are some main big ones as well. There's so much talent, so much interest happening in these places. The UK is in a very good position right now to work with everyone, with the US, the Europe, everyone.
Thank you very much. That takes us to the end of our time. So yeah, big thank you to Sarah.
Thank you.
Okay, next up we have Mark Stokes, co-founder of MagDrive. Yeah, welcome, Mark. And you can use lectern, roving mic, sitting, standing, dealer's choice.
Thank you very much, and thank you everybody for being here in the afternoon. My name is Mark Stokes, co-founder, CEO of MagDrive, and we're building high-power electric plasma thrusters for spacecraft today and deep space and further beyond tomorrow. The trade-off that companies and satellite operators currently make in space was the reason we founded MagDrive in the first place. We took a lot of the lessons we found in pulse power and nuclear fusion, tied to a very rapid prototyping phase for mechanical engineering, to build a system which bypasses the trade-off they make between having a chemical system with a huge amount of thrust and having very low specific impulse for maneuverability versus an electric system which uses xenon or krypton, which gives you the complete opposite. It'll give you very, very low levels of thrust, but excellent specific impulse and excellent efficiency for longer lifetimes. What we're building has the same high specific impulse as existing electric propulsion systems, but with a magnitude improvement in thrust at extremely low mass so that we can enable some really cool next level sci-fi stuff out in space, particularly mega constellations and making sure they stay up there and making sure they can dodge all the debris and incoming other satellites to keep them there forever, or as long as they need to be, to enable in-orbit servicing and everything from satellite rendezvous to satellite imaging, and also in our sort of defense aspect, making stochastic movement possible, which is essentially making defense satellites untraceable by enabling them to do long-term inclination changes and orbit raises above key adversary ground stations. So we've got a couple of MagDrives in the pipeline. The first one, the MagDrive Rogue, is going up in June of 2025 as our first flight, demonstrating the uniqueness of our metal propellant and that we can achieve extremely high thrusts with very low power input and also very low mass on board a host satellite. The MagDrive Warlock is going to be its bigger brother for 2026, and that's a continuation of the survivability of the system with more power going through it, detonating and ionizing more metal propellant to give it even greater levels of thrust in the same form factor. And the really great thing about having these pieces of standardized hardware is that we can deploy them in multiples, or in an array, a grid, if you like, of 2x2, 3x3, 4x4, which firstly lets us service anything from a 6-kilogram satellite all the way up to something weighing 350 kilograms. And we were considering at which point do we stop just strapping more MagDrives to each other and actually do we start just build something bigger. So we came up with the imaginatively named Super MagDrive, which is about the size of a dishwasher, 60 kilograms big, which will be able to do up to 10 newtons of thrust, still operating at the high specific impulse that you find with electric propulsion systems. The real benefit of using a metal for Super MagDrive is that it can be refueled, initially by using a metal cartridge system, which we're working in collaboration with Orbit Fab to sort of get the first ideas and decisions out. But then eventually we want to use the essentially existing metals that are in space. We want to use recycled satellites. We want to use the iron that's left behind by mining and processing lunar regolith. I even want to go as far as the asteroids to use the metals that are involved there as well. Our ambition is to keep building bigger and bigger systems till the day we die. This is kind of a lifelong passion project for me and my co-founder, Thomas Clayson, who was here yesterday, couldn't manage to stay today, but our combined backgrounds in mechanical engineering and like kind of high energy density plasma physics for nuclear fusion kind of means that we just want to keep building bigger systems until we even go back to the very initial idea that we had for MagDrive, which was a single stage to orbit, entirely reusable electric plasma launch vehicle. With the maths, what the maths tells us about a 20% payload mass, which sounds absolutely insane, but the maths all works out. The issue was that you need magnetic fields of about 40 Tesla around the entire ignition site for the whole ride to space, and obviously as a species we've done about 30 Tesla over an area that big for half a second. So we could either spend the next 50 years building magnets or get started building propulsion now, and we'll work our way all the way back up to it with the MagDrive Rogue, the Warlock, the Super MagDrive, and we're taking any inspirational ideas you guys have for less imaginative titles to go all the way back up to that final version. Yeah, thank you.
All I could think of was Mega Mag Drive. I don't know.
The team have already dismissed that one.
Dismissed it?
Yeah, this is not unique enough.
Wow. Okay.
So I can just push that through.
I won't say that personally. Okay, so if I understand, the Super Mag Drive is able to essentially refuel it, or able to use, you're looking at using metals to create fuel for it.
Yes. So the way the mag drive works is we use electric power the same way any other electric propulsion system does.
Right.
We draw power in from the onboard solar panels, but uniquely we store it up internally. And with a combination of high voltage generator and pulse power system, we can output it at extremely high cadence, about a frequency of 100 hertz or more, and output power of about 2 to 3 kilowatts, which is sufficient to ionize the metal propellant. With the mag drive Rogue and the Warlock, the propellant really is kind of built into a very small form factor. But with the Super Mag Drive, we'll have the freedom to operate in kind of within the form factor, essentially, in a much bigger system, where we want to build it so that it's modular, so that we can essentially have a cartridge system which can eject when it's spent and be replaced at specific sites, so that we're not just firing cartridges out into space either.
Okay, that makes sense. Yeah. Okay, so I mean, this really feels like the very kind of cutting edge of the ability to refuel in space. I suppose, what's the potential impact of this on some of the like emerging in-space activities that we're starting to see?
Yeah, the big area we're looking at is very long-term construction, in-orbit servicing and manufacturing, or IOSM in the UK, ISAM in the US. And the operations here are to just build the really huge space stations, as well as very large-scale manufacturing activities in space. A huge amount of money is already going into manufacturing medicines and incredible quality components and materials in space and bringing them back down to Earth. And it's just a capacity that they pretty much all have and they want to grow. The difficulty is in essentially scaling out that kind of facility and the sheer number of smaller satellites with their own onboard propulsion systems that get used up in the process of that construction, which makes the whole thing ultimately not economically viable. So the kind of companies we talk to have these very grand ambitions, and we see the Super Mag Drive being essentially the workhorse for a space construction site. Right now on Earth, if you were a hotel company or a factory producer, you don't build your own hotel, you don't build your own factory. You contract someone else to do it, and they take care of the whole construction, and then you move in. It's the model we see coming to the space industry. And the real competitor advantage that any company doing that would have is how many assets do you have to keep replenishing? If you were building a construction site on Earth and you had to use one truck once, and then you had to scrap it, or throw it to the side, or throw it down a ravine, you pretty quickly run out of rope as a company with capital to spend on this construction project. Whereas in this case, we can keep using the same assets in space over and over again to make the whole thing worthwhile doing, and then do the station keeping for those extremely large systems, all the way from LEO, all the way out to cislunar activities, including Lagrange points and GEO as well.
Okay, wow. It seems wild that these things that were once sci-fi now they're really happening, they're coming. I suppose, do you have a sense of, and I won't hold you to this, but what do you think the biggest, like the first sort of megastructures we're going to start to see in space might be?
Two types. The first one's going to be a sort of a lunar gateway for sure, kind of a stop-off point in space, using the moon as a place to get to the rest of the solar system, especially being able to refuel, but also being able to take on additional materials, drop things off for commercial purposes, and you'll see that grow to being essentially an extremely large warehouse for almost anything you could want to use in space or bring back. Instead of having to return it to space, you can return it there, and someone else can buy it from you at that point, at which point it becomes their problem. The other aspect is for humans in space. We're going to see a real uptick in the number of human beings living in space long term. We're moving away from a place where it could only be astronauts and military personnel doing research to tourism, but also civilian scientists as well, and having the capability to take more and more people to space, which means you need stations which are capable of not just sustaining 5 or 6 people. It's going to have to be hundreds of people, which is, I mean, apart from being really, really cool, it's definitely also the place like humanity for survival purposes should be heading in. And the last one is also a military kind of presence. Lagrange points, cislunar activity are all areas where a defense application is very interesting to basically secure it for their own purposes going further out into the solar system. There is very much a sort of Cold War in space. it's sort of NATO, the West, US versus China essentially, and they are looking at these Lagrange points as the next place to go to secure access for space going out and further into the solar system. So it's kind of a race of who gets there first. Is it going to be kind of, the DoD, or is it going to be a private company? Which creates a very interesting kind of Wild West aspect to space, which for one, I'm very much looking forward to.
Yeah, okay, super exciting, and even more need for space sheriffs as well. Okay, look, we got like 30 seconds left, but I just wanted to ask you, from today, who would be the ideal people you'd like to meet or connect with at Ignite?
Yeah, so we're moving soon into a manufacturing zone, as well as needing ever more precise components, both electrical and mechanical, for the MagDrive Rogues and Warlocks. So anyone developing very precise machinings, able to deliver at high volume, very interested in that for space-rated components. But we're also closing a major funding round soon, so anybody on the investment side and venture capital areas, very interested in having a conversation as well.
Mark, thank you so much for your time.
Thank you. Thank you very much.
Okay, we have two more businesses as part of our highlight hour. I'd next like to introduce Trevor Pearson from Scorpion Vision. And again, you're welcome to use the lectern, roaming mic, walk around or sit down, totally up to you.
Hello everybody, thank you for coming. My name's Trevor Pearson and I'm with the company called Scorpion Vision. We're a SME company based in the south of England, but I'm actually based in the north of England. I'm sure you can tell with my northern Yorkshire accent. I'm based up in Skipton. Now, Scorpion Vision, we are an SME and we supply anything to do with imaging equipment. So as a components, that could be lenses, embedded cameras, 2D cameras, 3D cameras, filters, the components, you get it. And we also have the vision side, machine vision side, where anything to do with automation. So as an example, we supply or make a product that can decore vegetables and also, very diverse, also to robotic guidance systems. Now, I heard some of the speakers earlier talking about imaging equipment. We're looking to collaborate with companies, small and large, on supplying them the components, i.e., as I mentioned earlier, we could do lenses, M12 lenses, those type of products. And also we have an innovation side, so some of the products that we make have AI involved, so smart cameras, and we use neural networks to be able to differentiate between, say, a scratch or a dent or something that's supposed to be there, like on a profile. Now, for space, we supply what they call time-of-flight cameras. So that could be really good for collision detection. And if there's, say, an eclipse and it's dark, clearly you're not going to be able to see. But with our time-of-flight, you'll be able to use our infrared technology to be able to monitor that. So why we've come into space is we're in agriculture, we're in automation, and we're in automotive, and space seems like the next place to go, really. And we're here today to actually speak to companies very similar to yourselves to see if there is something we can help you with regarding the imaging side of any of the applications you have, like with satellites, as an example. So, once again, my name's Trevor, Scorpion Vision. We're a local company with a global reach. So if you have applications overseas or in the UK, we'd be more than happy to talk to you about that. Thank you.
Come and have a seat in my open plan living room.
It's very comfortable.
Yeah, it is, isn't it? It's probably one of the most comfortable sessions I've chaired. So, okay, an incredible range of applications you've talked about, from like vegetables to satellites.
Absolutely, yeah.
And what has you mentioned that you're entering into the space sector. What's that journey been like in terms of almost knowing where to go, where to find the right businesses who might be potential partners or customers to your technology?
Okay, well, to start with, we were just doing research, but we're so fortunate as a company, because we're so niche, we've actually been approached by space companies in the United States, as well as in the UK, and it's amazing how many applications need vision. And the products that we supply, as an example, are embedded cameras. They're very low power and also very low cost. And so that's been our journey, and I think that's where our market is going to be, really.
And how is the kind of emergence and development of AI technologies, because I guess that's quite intrinsically tied to kind of computer vision, how is that potentially opening up new applications and possibilities?
Oh, wow, that's a great question, Josh. Thank you. With the advances in AI over, say, the last 5 years, it's enabled us now to be able to teach the cameras what to look for. So, as an example, if we're looking at debris, we want to make sure we can teach the camera to say, right, that's damaged, that dent there or that cavity there is supposed to be there. It's so advanced now, and we're able with our engineers to actually teach the cameras what to look for, and that's a real advantage.
And in terms of the sorts of people that you're looking to connect with at Ignite, is that the people who are manufacturing the kind of satellites for in-space activities? You're looking for kind of Earth observation companies, or is it kind of broad brush?
Yeah, all of the above. Like earlier, I heard a chap was talking and you mentioned GoPro. So if you're using a GoPro, we're able to supply a product that's lighter, more cost-effective, and smart. And so it's the other SMEs, very similar to the companies that are here. And the large ones like Airbus. I'd love to talk to Airbus, who wouldn't?
I think they're around somewhere.
I'm going to look him out. I'm looking for him.
In terms of computer vision applications, trends you're seeing, what are some of the new applications of computer vision, optical technology that have opened up because of the way the technology has emerged?
Okay, I can tell you as an example in logistics. What's great now with logistics, before you'd have a robot, and if something was in front of the robot would still keep going. Now, with our technology, the robot can see there's an item there, it will turn left, turn right, go and pick it up. No, it's not the right unit. Why? Because it's too heavy. It's not just to do with the barcode, it's not just to do with the QR code. So the advances are real and good.
Hearing the other applications being talked about in terms of large-scale construction in space, the maintenance as well of satellites, I guess they're all applications that are also kind of requiring the optical side as well.
Oh yeah, absolutely. So maintenance, quality control, and being able to monitor with clarity.
Yeah. Okay. And I guess, my last sort of question is, what would you like people to know about the company that, in order to know how to approach you, what they should be getting from you?
Okay, so Scorpion Vision, we're very collaborative, we're a friendly company, and we're very approachable. So no questions too technical and no questions too simple. Please, we're on stand number 18, come and say hi, and you'll get a big smile and a handshake.
Nice. Trevor, thank you so much for your time.
You're so welcome. Thank you.
So we've had launch, we've had ability to robotically grab, moving around in space, computer vision. I guess the piece that's missing is maybe around communications, radio frequency. Luckily, would you believe our next company is Slipstream Design. So I'd like to welcome up Sarah Gregory, the commercial director. Sure.
So hello everyone, I'm Sarah Gregory and I'm Commercial Director at Slipstream Engineering Design. So in essence, Slipstream, we are problem solvers like most of everybody that's in the room, I'm sure, but we are deeply geeky. The focus for our geek is really digital RF. So we take radio frequency waves that are all around us, that are sort of we've become completely dependent on them, haven't we? And we take those radio frequency waves and translate them into ones and noughts. And then we stream them at really high speed to get the data off, and we do that just for fun. So, yeah, we're quite niche, I guess. But to tell you a little bit about our journey, we're a business that is now 13 years old, and we've started in a garage, a bit like Space Forge. They had a lovely picture of their garage earlier this morning. And we've bootstrapped our way up to now being a multi-million-pound company with a team of over 21 really specialised and extremely intelligent engineers. And through that journey, we've built up a customer base of large primes, but also really ambitious SMEs who, I guess, want to change the frontier of digital RF, and they want to change the way in which we communicate and the way in which we sense the world around us. So I guess, yeah, it's been an interesting journey, full of tears, lots of late nights, but ultimately we're in a position where we can really take stock and build on that stability of the company that we've created. And how we're doing that now is really translating the stability and dreaming big, and now we're investing in our own R&D. And what that looks like for us is really wideband communication systems that are able to switch from, say, 5G waveforms to radar waveforms within an instant. And can you imagine the power of a payload if it could do that? So we set our sights on space, and that journey has again been bootstrapped, and that's not easy, getting into the space sector when you're a small company. But we've had some really great help along the way. We've had some funding from DARSA, so the Defence and Security Accelerator. And we've also had a lot of support from the regional space cluster in the form of Space Hub Yorkshire. And without those two, I guess, support mechanisms, then we probably wouldn't be standing here today. So yeah, I guess I'd really like to just say if there's anybody who is super interested in wideband communication systems, if they'd love to come to our stand, we're at stand 38, which is just as you come in. Yeah, so we could talk more. So thank you.
Come and have a seat. Okay, so my first question is, you talked about that ability to switch wideband frequencies, and as a non-expert, can you explain to me why that's important? What does that enable if I didn't know anything about frequencies and what they can do?
Yeah, sure. So it's quite technical, but the RF front end, so the bit that sends out and receives the radio waves, is usually pretty specific, and it takes a lot of effort in which to get it right, a lot of non-recurring engineering effort, and time, cost, money. Usually it's hardware specific, and what we're really trying to break the back of is to make that reconfigurable. And in particular, we have a focus on power amplifiers, and we are able to switch between different frequencies but maintain efficiency. And that's something that's quite unique in I guess, a radio unit situation. We couple that with our knowledge of the digital front end, which is the bit that takes the waves and translates it into ones and noughts and then streams it out. And that combination, I think, is something that you don't find very often. There's a very small pool of engineering talent in the RF sector, and even smaller that know about RF and digital.
Okay, thank you. And then the types of applications that enables, is that more like terrestrial on Earth, or is that in space activities?
So I think it's both. To date, our activity in the space sector has been terrestrially based, so that is development of ground terminals, communication systems. But I think it absolutely has applications in mission in space. And I say that because once you launch something, you can't change it, right? Yeah. So our technology will be able to be reconfigurable by sending a new update. Okay. Whereas traditionally you wouldn't have been able to do that because you have a fixed hardware payload that you can't change.
Okay, that makes a lot of sense. Thank you. You mentioned the support you got from Space Hub Yorkshire.
Yeah.
So that's one of our space enterprise ecosystems, or UK space ecosystem clusters. What has that support been? How have they helped you? And how did you get in contact with them in the first place?
Okay, so I guess the way in which they've helped is just by highlighting the RF cluster that exists in this area, in this region in particular. They've brought us together, they've enabled us to network, and then they've brought into the region this event. So we have this platform because of them. And also this morning we were at a networking event where the likes of Lockheed Martin were there, Airbus. So it is enabling us to, I guess, bring in that external gaze to the companies that are here, that are super ambitious and really innovative, and they're giving us a platform. So I'd say that's the way in which they've helped the most.
Nice, thank you. And is there any additional support you'd like to see in the ecosystem that we could be developing?
I guess, support in people have talked a lot about developing talent, and it is pretty tough as a small business trying to recruit and retain engineers that know about the tech that you want them to know about and then know about the space sector. It's like you fish in a smaller and smaller pool. So I think any help around that area, ensuring that there is, the university courses available for a start, but not only that they're then being retained in the UK, I think that would be a real help.
Thank you. And I guess lastly, who would you like to connect with from today? Who would be the ideal people to come and talk to you to see you at your stand?
I think, from a geek perspective, anybody who's super interested in wideband communication systems, because that's just what we love. But I think we're really open and collaborative company, and we've put together many a research proposal with other collaborative organisations, whether that be academia or large and small organisations. So I think anybody who's open to exploring connectivity and radar in particular would love to hear from. But we're happy to share our story. We're happy to share the lessons that we've learned just from growing a business. So really anybody who wants to come and talk to us, we'd welcome. And it's Stand 38.
Thank you so much, Sarah, for your time and for sharing your story as well. Looking forward to speaking to you outside at your stand and hearing more about the wideband communication.
Thank you. Thanks for the opportunity.
And I'll check if there's been any questions on the live Q&A as well. The answer to that is a swift no. They haven't, so that's reasonably quick. Please just one more round of applause for all of our speakers and all of the businesses who came up today. And with that, I'm going to relinquish my comfy chair and speak to you all on the floor.